This lecture is going to be about literate statistical programming. In the lecture about reproducible research, I talked about the basic ideas of what it means for an analysis to be reproducible. But now I'm going to talk about one of the tools that you can use to actually make your analysis reproducible by others, or at least help other people to kind of reproduce your analysis. And one of the ways that we talked about making reproducible documents is with this literate statistical programming concept, or just literate programming. And so the basic idea is that authors have to undertake a lot of effort to put data and results on the web, and even when they put that stuff on the web, they're all kind of separate. The data is over here, the code is over here, and you kind of have to figure out, well, which code goes with which data, and how do you execute this code, and you have to load this first, and you have to do this first. So there can be a lot of confusion, even when everything is just available. And so one of the ways that you can simplify that process is to put the data and the code together in the same document, so to speak, so that people can execute the code in the right order and the data are read at the right times. So you can have a single document that integrates the data analysis with all the textual representations, so the words that you use to describe what's going on, and so you don't have to have everything kind of in separate pieces, but everything is kind of linked together. So the original idea behind literate programming comes from Don Knuth, who was a computer scientist at Stanford. And his original system was for writing just regular computer programs and kind of documenting the computer code at the same time as writing the code. So the basic idea translates over to a literate statistical program where you want to document your analysis and similarly have the code for your analysis in the same document. And so the idea is that an article is a stream of text and code, and analysis code is divided into text and code chunks. And so the presentation code formats the tables and formats figures, things like that. There's article text that talks about what's going on. And in these literate programs, there's two concepts. You can weave them into human-readable documents, and you can tangle them to produce machine-readable documents or just code files. So literate programming, as I said before, is a general concept. You need a documentation language and a programming language. So the original SWeave system that I talked about before, written by Fritz Leicht, used LaTeX as the documentation language and R as the programming language. So on this lecture I'm going to talk about knitr, which supports a variety of documentation and programming languages. And so the first thing you want to start with, so the basic question is, how do I make my work reproducible? And the basic answer to that is that you have to decide to do it, okay? And you can decide to do this at any point in your analysis, but it's usually easiest to do it at the very beginning. If you decide at the very end that you want to make your analysis reproducible, then it often is much harder to do, and maybe even impossible. And so we want to keep track of things as you go along. You could use a version control system like Git or SVN. I won't talk about that here, but if you've heard of that, then it's a good thing to learn. It's important to use statistical software whose operation can be coded. So the idea is that you can write down the instructions that were used to manipulate or analyze the data. So this generally rules out graphical user interfaces unless those programs will code or keep track of all the clicks that you make on the graphical user interface. But systems like R and other types of packages, because you have to program them explicitly, the code, as long as you save the code, will have everything that will store everything that you did to the data. Another key lesson is to not save any output. By output, I mean mostly kind of temporary data transformation types of objects. So if you pre-process the data and have a kind of clean data set, rather than store the clean data set, it might be better to have the kind of raw data set with the pre-processing code, because then you not only can you make the final product, but you can see how you got there. If you just keep the clean data set and maybe you accidentally lose the pre-processing code, then you don't really have a good record of how you got from A to B. And so try to keep, rather than keeping temporary products or even final products, try to keep the original products and the code that got you there. And that will make it easier to understand what you did and how you got to the data that you ended up analyzing. So not saving output is, I think, a key element of reproducibility. And try not to save data in non-proprietary formats. So these are data formats that are not where the layout of the data set is not publicly known. There are not too many proprietary formats out there anymore that are commonly used like there were before. But a lot of them, for example, products will store data in it because it's much more efficient in a proprietary format, but then that makes it difficult to transfer to another person if that person doesn't have the same exact program then they won't be able to read the data. And so using non-proprietary, even textual formats, maybe compressed, can be much better at can make your research a little bit, or analysis, more reproducible than proprietary formats. So there are a couple of pros and cons when it comes to the literate programming style. This is not the only tool that you can use to make your work reproducible, but literate programming is just one of the tools. And so some of the pros are that it forces you to put all the text and the code of your analysis in one place, so it occurs in a logical order. All the data and the results are automatically updated to reflect external changes. So if you have this live document, and if you make some changes, when you reprocess the document, it will automatically update itself to reflect any changes. So you don't have a situation where numbers will be out of date or things will be mismatched because the code will kind of automatically recalculate everything. Because the code is live in the document, in the sense that you have to run the code in order to produce the final document, that's the weaving process. You get this kind of regression test, so to speak, not like linear regression, but regression test to see so if there are any mistakes that you introduce into the analysis. If the code doesn't run, then you know you've made an error, you've introduced a problem. So the running of the live code will kind of keep you from introducing new errors into the analysis. Some of the cons when it comes to literate programming are that, of course, the text and the code are all in one place. And so in particular, if you have a lot of code, or if you have a very complex or lengthy analysis, then you're kind of like a human readable text is going to be mixed in with all this code, and it can make it difficult to edit the document because you have to somehow search through this whole document to figure out where the text is and amongst all the code. So that can be a problem for the author. Also, if your analysis is very complicated, and you have to reprocess this document every time you want to see a human-readable version of it, it can substantially slow down the process by which you build the document.